Unlike a simple column, this 200-foot tower is a vertical sorting machine. Crude oil passes through a scorching hot furnace before entering the flash zone. A portion of the crude oil flashes while some flows across the plates. In fractional distillation, you have a bit more going on as multiple components are being separated from the crude oil in one column. The feed is being distilled off at specific plates based on its boiling point. At the very top of the column, you have a mixture of light naphtha, incondensable gases, and water which is passed through a condenser and is separated via a reflux drum which typically acts as a three-phase separator. The water is known as sour water and is removed from the bottom of the reflux drum. This is called sour water as it's high in sulfur and is foul-smelling. The incondensable gases such as methane and ethane are removed from the top. Meanwhile, the light naphtha, which is commonly used for plastic manufacturing, is either recirculated back into the column or removed and made ready for storage. A few plates below you could have heavy naphtha or kerosene which has a higher boiling point and is distilled off a few plates lower down the column. Let's use kerosene in this example. This is where it flows into the top of a side stripper. At the bottom of that mini-column, you see a line for steam. This steam rises through a few small trays or packing inside the stripper which will be discussed in another video. Steam injection is present to increase its temperature to aid separation. The steam carries enough energy to vaporize any light molecules, like naphtha that accidentally got into the kerosene, without boiling the heavy product itself. The steam and the stripped light molecules travel out the top of the side stripper and are refluxed back into the main column 1 or 2 trays above where they were originally drawn. The cleaned kerosene, now with the correct flash point, leaves the bottom, goes through a cooler, and heads to storage. By the way guys, if you are enjoying this video, please make sure to like, comment and subscribe. Next we move on to the bottom section of the distillation column. In a standard distillation column, you'd use a reboiler to boil the liquid. But in crude oil refining, we use steam injection at the base for a very specific thermodynamic reason. In the bottom of that tower, you have the heaviest, goopiest hydrocarbons known as residue. They have extremely high boiling points. If you tried to boil them normally, you'd have to reach temperatures so high that the oil would crack and the molecules would literally shatter into charcoal-like coke, ruining your equipment. By injecting steam, the steam molecules take up space in the vapor phase. This reduces the partial pressure that the hydrocarbons feel. The light parts of that heavy residue can evaporate at a much lower temperature, well below their normal boiling point. This allows them to escape up the column to be recovered as product. Meanwhile, the remaining residue is then removed from the bottom of the column and sent to storage for further processing. You also have a pump configuration on the side of the column called a pump around configuration. This is strategically placed between 2 different product draw-off points. Its primary purpose is heating management and vapor control. In a column this size, the rising vapor carries a massive amount of heat. If you only cooled the vapor at the very top via the condenser, the top of the tower would be overwhelmed with heat while the middle remained too hot to separate the liquids properly. The pump around takes hot liquid from a lower tray, cools it in an external heat exchanger, and sprays it back into the column a few trays higher. This shocks the rising vapor, causing the heavier parts of that vapor to condense into liquid right there in the middle of the tower. If you haven't already, check out my previous video on how a distillation column works